Hello, everyone. Today we are diving into the world of aviation and talking about the first American mass-produced fighter jet, the Lockheed F-80 Shooting Star. Why did this aircraft become iconic and what are its distinctive features? Let's find out. The United States was relatively late to join the jet aviation race. This is not surprising. Creating a fundamentally new field of technology without significant government support is practically impossible in modern conditions. First attempts. In October 1942, Bell began flight testing its XP-59A Aerocomet, the first jet fighter developed in the United States. During testing, it was determined that this aircraft did not have any decisive advantages over piston-engine fighters and was of no interest to the Army. Plans to produce the XP-59A were sharply curtailed, and it was decided to develop a completely new aircraft. By this time, the US and the UK had agreed on the sale of the latest Halford H-1 turbojet engine, later designated the de Havilland Goblin. Bell was to develop a new aircraft using this engine. It was designated the XP-59B. However, this project was soon abandoned. Bell was busy with orders, so they decided to give the jet fighter project to Lockheed. In May 1943, the new contractor got the paperwork for the XP-59A/B and the promising engine. Plus, the Air Force gave them the technical requirements for the future plane. The preliminary design started. On June 15th, Lockheed presented the first version of the project with the brand name L410. It was prepared by a group of engineers led by young designer Clarence Johnson. Subsequently, they were entrusted with the further development of the project. Just 2 days later, the customer approved the project, and preparations began for signing a contract for the work. On June 24th, the U.S. Army Air Forces and Lockheed signed an official contract for the development of the XP-80 fighter with an H-1 engine. Only 180 days were allocated for design work and the construction of a prototype aircraft. Flight tests were scheduled to begin at the end of 1943. All work was to be carried out in secret in a separate building on the factory premises. A group of 23 engineers led by Kelly Johnson was responsible for the design. The designers chose a laminar profile wing with minimal aspect ratio. The aircraft had a conventional tail and a tricycle landing gear with a nose wheel. The Halford N-1B engine had air intakes at the wing root. The engine nozzle exited at the very tail of the aircraft. The pilot sat in a pressurized cockpit under a teardrop canopy. By the beginning of August, 105 workers were working on the XP-80 prototype, and the designers had to overcome a number of difficulties. The need to meet tight deadlines led to the temporary abandonment of some solutions. It was decided to build the first prototype without a pressurized cabin and with simplified equipment. The aircraft was nicknamed Lulu Bell for its neat appearance and elegant contours. After being painted in standard Air Force colors, it was given the name Green Hornet. The Halford engine was delivered to Lockheed in mid-November 1943. The de Havilland H-1B turbojet engine developed a maximum thrust of 1,362 kilograms at 10,500 revolutions per minute on the test bench. On November 17, 1943, the H-1B engine was tested for the first time on the XP-80 for ground tests. As a result of the startup, both of the aircraft's air intake ducts were destroyed. The engine, which suffered minor damage as a result of the accident, was examined, revealing a large crack in the compressor, which was not caused by the accident but by fatigue failure. The engine could no longer be used. While waiting for a new engine, the air intake ducts were reinforced. The accident with the air intakes practically saved the aircraft. It later became known that due to similar fatigue failure of the metal centrifugal supercharger, there had been 9 serious accidents on the test bench. The new engine was received on December 28th and immediately installed on the XP-80. A couple of days later, on New Year's Eve, the engine showed full power during a test run. Finally, the aircraft was ready for its first flight. On January 8, 1944, the XP-80 prototype took off for the first time under the control of pilot Milo Burkham. The flight lasted only a few minutes. The test pilot was unable to retract the landing gear and noted excessive sensitivity of the ailerons, which forced him to land. The necessary adjustments were made on the ground, and a second flight took place. Within 20 minutes, Monsieur Berchem determined the approximate speed and maneuverability characteristics, controllability, etc. The first stage of flight tests lasted just over a week. It was possible to reach a speed of 750 kilometers per hour and determine the maneuverability indicators. However, subsequent flights revealed poor spin characteristics and a high stall speed. After the flaps were released, the aircraft could suddenly veer to the right without warning. In addition, there were high loads on the control stick, the fuel system did not work satisfactorily, and the engine was unreliable and clearly lacked power. After modifications, the P-80 was transferred to the 412th Fighter Group for military testing. On February 12th, despite the engine's thrust being limited to 75% of its power, the P-80 became the first American aircraft to exceed a speed of 800 kilometers per hour. Technical characteristics. Crew, 1 person. Wingspan, 11.29 meters. Wing area, 22.33 square meters. Aircraft length, 10.00 meters. Aircraft height, 3.12 meters. Halford H-1B turbojet engine. Thrust, 1,362 kilograms. Empty aircraft weight, 2,854 kilograms. Normal takeoff weight, 3,720 kilograms. Maximum speed, 810 kilometers per hour. Climb rate, 915 meters per minute. Service ceiling, 12,500 meters. Armament, 6 times 12.7 millimeter Browning, M2 machine guns, ammunition, 6 times 300 rounds, combat load, 907 kilograms located on 2 suspension nodes for mounting 454 and 227 kilogram bombs or 5 127 millimeter rockets. Variants P-80A, later F-80A. Production variant equipped with a General Electric J-33GE-11 turbojet engine with a thrust of 1,746 kilograms. Armament consisted of 6 12.7 millimeter machine guns. 917 aircraft were built. P-80B, later F-80B. Production variant with ejection seat and equipment for takeoff with a rocket booster. 240 aircraft were built. P-80C, later F-80C. Production version, initially with J-33, A-23 jet engines, with a thrust of 2,087 kilograms, and later with J-33A-35 engines, with a thrust of 2,449 kilograms. RF-80C, designation of 70F-80, a variant aircraft converted into reconnaissance aircraft. Operation and use. The F-80 Shooting Star was the first mass-produced jet fighter to enter service with the USAAF. In 1947, after a change in the U.S. Air Force designation system, when the letter P for pursuit was replaced by F for fighter, the Shooting Star was given a new designation, F-80. It had a simple design, which was traditional at the time, allowing it to become a real workhorse of American tactical fighter bomber aviation and remain in this role for 5 years after the end of World War II. Although the F-80 did not see action in World War II, it played an active role in the Korean War, where it proved to be a versatile and effective aircraft. The F-80A was followed by the F-80B and then the F-80C, which became the most widely used variant. The F-80C was widely used as a fighter bomber during the Korean War. In just the first 4 months, these aircraft flew 15,000 combat sorties. Pilots considered this aircraft ideal for low-level attacks. On November 1, 1950, MiG-15 and F-80C squadrons met in combat. Soviet pilot Semyon Komenich shot down one shooting star. Pilot Frank Van Sickle was killed with an attack from the sun. This was presumably the first air battle between two jet aircraft in history. The MiG-15 with its swept wings significantly outperformed the F-80, so starting in December 1950, it was replaced by the F-86A Sabre. In addition, Lockheed F-94 Starfire all-weather interceptors, based on the F-80A, were used in Korea. According to official U.S. data, during the entire period of F-80 service in the USAF, fighters of this type destroyed 18 enemy aircraft, including 4 MiG-15s, in air combat. All victories were achieved during the Korean War, 1950 to 1953. At the same time, 371 F-80Cs and 28 F-80 reconnaissance aircraft were lost, not counting the T-33 trainers. Some aircraft ended up in private hands. So there you have it, friends. The F-80 Shooting Star is not just an aircraft, but a symbol of an era that influenced the future of aviation. If you enjoyed the video, don't forget to subscribe to the channel, like it, and write in the comments which aircraft you would like to learn about next time. See you soon.